Hello there, you beautiful people. So in the last video you learned that there is something called the shell that is interpreting the commands that you type into the terminal. Now, one reason that Linux is amazing is that the commands that you type all follow a similar type of structure in the way that you type them. Now, by understanding this structure, you'll be able to transition from simply just memorizing commands and hoping for the best to actually understanding the common language that all Linux commands use, and that will give you a massive boost in your abilities. So in this video, you're going to learn what commands actually are and how they are structured. And by the end of this video, you'll have a much deeper understanding of what commands are, and the commands themselves will actually start to look like a language rather than just random gibberish on the screen. So this is going to be a very game-changing lecture that, if you understand fully what I show you here, it'll make your work with the terminal so much easier. So let's not waste any time and get right into it. Okay, so the first thing you need to know is that all commands are effectively just little computer programs that are installed somewhere on your computer. So for example, date is a program, cal is a program, echo is another program, and so on. Now, the command or program name that you want to use is always the first part of the command. So we'd start our command with the word date, or with the word cal, or with the word echo, like you saw before, right? Now, each command has its own unique behavior that you can actually look up using something called the manual pages, which I'll show you how to do later in this section of the course. But the general command structure goes like this. First, you type out the command name, so that would be like date, cal, echo, whatever it would be. Then you give the command some options to customize its behavior. Then you give the command some inputs to actually operate on. Now, the first thing you type is the command name. Now, that lets the shell know what program you actually want to run. And once the shell knows what program you want to run, or it knows the name of the program you want to run, the shell will then search for that program on something called your shell's path, which is just a list of folders that contain these programs. Now, you can actually see your shell's path by typing echo, then a $, then path. Okay, so echo, space, then $, then path, and you press enter. And you see this terrifying output come out, but it's actually very easy to understand once you notice that these are just different folder paths, each separated by a colon, by these two dots here. So, for example, there's a folder here that's called /user/local/sbin. Then you've got another folder here, /user/local/bin. Then another folder here, and another folder here, and another folder here, and so on and so on. Okay, so what the shell will do is it'll start at the very left of the path, and it will look inside that folder for a command called echo, or called cal, or called date, or whatever you called it. Okay, so it will look in the leftmost folder, and it will, if it doesn't find it there, it'll move to the next one. So it would start at the very left, then it would move to maybe to this folder. Okay, then if it didn't find it there, it would move to this folder, and if it didn't find it there, it would move to this folder, and so on and so on and so on, until it got right to the end, so to /snap/bin. Okay, and if it didn't find a folder with that name in any of those folders, okay, then the shell would give you a command, an error like command not found. So if I tried to do blah 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 and tried to call that as a command, it says it couldn't find this command. So what the shell did is it looked for a command called this in each of these folders, didn't find it, and said command not found. Now, this has an interesting impact. The fact that it reads from the very left all the way to the very right. Let's say you had a program called blah, okay, and blah was actually in this folder here, /user/sbin, but it was also in the very far left folder. Which one do you think will actually be run? Well, actually what would happen is it would only run the version in here, because that's where it found it first. And if you wanted it to run the version that was in this folder, that wouldn't be possible because it found the same name here first. Okay, so that's just something to bear in mind. It's not something you'll really run into, but it's just something to bear in mind. Okay, now you can actually see which folder that a command is stored in by using the which command. So it's like, which folder is this command in? So I could say which and then cal. Okay, and if I press enter, it'll tell me that the cal command is actually in the /user/bin folder. And if we look at our path, we can see that /user/bin is located here. So it is on our path, and therefore cal was able to be found. And let's try that again for echo. If we do which echo, you can say /bin/echo. And if we look on here, we'll find somewhere /bin is somewhere, here we are, /bin. There we go. So slash bin is also on our path. You can actually also look at the which command. So the which of which. which folder is the which command in? And we see it's in slash user slash bin, which is here. There we go, slash user slash bin. Okay, and we see the which command also runs as well. So that's how the shell knows where to find your commands. Now you can customize the way that commands work by giving them different options and different inputs. Let's go ahead and start with the inputs. So it's important to note that not all commands actually require inputs. Some inputs are optional. For example, the date command doesn't strictly require an input. You can just type date and be done with it. Okay, but most commands do require some form of input, which can actually have a fancy name called an operand. Okay, because commands operate on the input is sometimes called an operand. Okay, so to give the command an input or an operand, you simply type a space after the command name, then type the input. Okay, that's assuming you don't have any options. So for example, if we take the cal command, I could just type cal, okay, and press enter, and I would get this month's calendar. But to customize the behavior, I can give it an input. So for example, if I want to get the calendar for the year 2017, I could type cal 2017, okay, and if I press enter, now I get a completely different input, output, sorry, because I gave the command this input. Okay, you can also give more than one input. So let me clear the screen using Control and L, the nice shortcut. Sometimes you can give more than one input. So for example, I could type cal 12 2017, and if I press enter, you can see now that I get I've given the cal command two inputs. One being 12, which means the 12th month, and the next one being the year, which is 2017. So I've said here, can you give me the calendar for December 2017? Pretty cool, right? So we gave it two inputs, and that also customized our output. So basically, you can just give commands inputs. So like if I say echo and I say hello, then hello, was the input to the echo command. You see? So that's quite straightforward. All we did was type the command name, which the shell then found on the path, and we gave that command, that program, some input. Okay, so now that we understand inputs, let's discuss options, because this is where stuff gets really interesting. Okay, you've seen us use an option with the cal command as well. So the cal command, we gave it the Y option before. Okay, so if I do by default, the cal-y will show the current year's calendar. Okay, so we gave the cal command an option, the Y option, which you can see that has been preceded by this dash, and that's common for commands. They tend to be preceded by dashes and hyphens and things. So let's take a look at the date command to understand how options work even better. Okay, date by default will show today's date in our current time zone. So if I just say date, it says here's the date and time in the current time zone, which is apparently British summertime. Okay, so to get the date in universal time, such as UTC or Greenwich Mean Time, we can type date/U, and we can see now that the hour has gone back one. Okay, because now we're in UTC rather than British summertime, which is currently an hour forward. So we gave the date command the U option. Now, if we had other options to give the commands, we could list them right after one another. So, for example, we could do date/A-B-C-D-E-F-D, and this would give it these different options. So the A option, the B option, the C option, the D option, the E option, the F option, the G option. Okay, or more simply, you could just do -A, B, C, D, E, F, G. Okay, that's a nice shortcut. You can just stick them all together like that. Okay, now this specific example doesn't work, so if I try that, it will say invalid option, but it just illustrates the point that if you chain these options together, you can actually chain them together, and the order doesn't really matter. So I could do date G, D, H, G, E, F, A, and it would have exactly the same effect. Okay. All right then. So now it can sometimes be difficult to understand what these options mean. So sometimes options actually have long form names. So for example, date/U, okay, -U, sorry, which gives us the date in universal time. You could also do date --universal. Now and it gives us the same output. Now universal long names are preceded by two dashes. So you see a --universal. Whereas the short form options, which are just one letter, are usually just preceded by one dash. Okay. Now, the long form commands can make commands easier to read, but they're not available for all options. It really depends upon the command that you're using. And again, just notice the fact that I use 2 dashes for long forms and 1 dash for short form commands. Now, if you wanted to use, for example, 3 long form options, you would need to do something like this. So you'd have to do date dash dash universal. That's 1 long form option, then dash dash long form option 2, then dash dash long form option 3. You can't really chain those together like you can with the short form options. Okay, so that's not going to work. But the short form options, you can do date slash ABCDEFG. But with long form options, you kind of have to separate them. Dash dash universal, dash dash long form option 2, and dash dash long form option 3. Okay. Now, it's important to note that everything on Linux, including commands, is case sensitive. So, for example, the date command in lowercase is valid. So, the date command in lowercase is valid, but the date command, like with a capital D, would not be valid. The date command with like a capital A here, that would not be valid either. So, you need to make sure that you spell your stuff correctly and with the right case sensitivity, and that goes for options and inputs too. So, it's not just the name of the commands. The date command, for example, has a U option, but I don't think it has a capital U option. See, it doesn't. So I put a capital U and it didn't give me the universal output because it doesn't know that it has a capital U option. It only knows that it has a lowercase u option. So make sure that you spell your commands with the right case sensitivity. Now, the only other thing to know is that sometimes options can have their own inputs. So, for example, if we go to Cal, I'm going to clear the screen. If we go to Cal, we could see the calendar for December 2017 by giving it 2 inputs, right? Cal 12 2017, not options, 2 inputs. But there is an option that will allow us to see a certain amount of months after that too. So, for example, if I did Cal, gave it the capital A option, then wrote the number 1, 12 2017, okay, this will show December 2017 with 1 month after. And the A option gives you after, but it also needs to know how many months after. So I said 1. So this 1 here is actually an input to the A option. And then you've got the inputs for the command. Okay. You can also show a month before. So for example, cal-b 1 12 2017. That will show us December 2017 with 1 month before it. And you actually also combine these together. So cal 1 month after, 1 month before of December 2017. Okay, so now you've got December 2017 with 1 month after, which is January 2018, and 1 month before, November 2017. So here you can see how you can actually provide options with their own inputs, and how options are okay to use when you give commands its own input. Okay, so you can use, there's loads of different ways to combine this stuff together. So here we have the A and B options with their own inputs, and the cal command has its own 2 inputs, 12 and 2017. So this is starting to get a bit crazy, right? Like it's starting to get a bit advanced and a bit hairy. But this should just begin to highlight just how powerful Linux commands can actually become. And then the only other thing you might need to know is that some commands allow you to put an equal sign to match up those options with their appropriate inputs more explicitly to make stuff a bit easier to read. This doesn't work for cal, but if it did, it would be something like cal after equals 1, before equals 1, 12 and 2017. Now that doesn't work for cal because its manual page doesn't let it happen. So we only get 12 2017. That didn't quite work, but that's how it would work if it was possible for the cal command. And it might, it might just make it a bit easier to read that the options are linked up with their appropriate inputs. If there were long form options, you would do something like cal -- before equals 1 -- after equals 1 and 12 2017. So here, you've got long form options also being linked with their inputs. Again, that's not possible for the cal command specifically, but you can see how features like that, joining up the inputs with the actual options can make commands easier to read. So in this admittedly rather in-depth video, you've learned that commands are basically broken up into 3 main parts. First, you've got the command name. Then you've got some options, which are preceded by dashes and hyphens, and you've also then got some inputs for the command. Now, the command name needs to match a program that is on the shell's search path. Now, the path is just a piece of text that's stored in the shell that lists a bunch of folders that the shell will start searching from the left to the right, separating each folder with a colon, which is the two dots on top of each other. And if the shell finds an appropriate program, then that program will run, and the shell will pass to that program any inputs that you have given it in the command. Okay, so you can also customize a command's behavior using options. Now, options are usually just letters that are separated by hyphens, so a dash, like you see at the very top of the summary slide here. You give each option a dash before it, or you can chain the little letters together in one go. The order does not matter. And sometimes they have long form versions which need two dashes but allow you to use easier to read words. So instead of having -u for the universal option, you can use -- universal. Okay, but that really depends on whether the command allows that to be possible, and each command is slightly different. And one thing that became very clear in this video is that each command behaves very differently to other commands. So for example, some commands can take multiple inputs and others take none. Some can take long form options and others can't. Some can have an equals sign to match option inputs with their appropriate option and others can't. So now that you understand the overarching command name, then options, then input structure that commands follow, and the different ways of implementing that and the different options that you've got, how can you know what is possible for a specific command and how you use each specific command? Well, each command actually comes with their own manual page, or man page for short, that shows you how to use them. And in the next video, I'm going to be showing you how to access and read the man pages. So just imagine having all the deets on a big catalogue of computer programs just sat there waiting to be explored. Using the man pages is going to be a complete game changer for you if you want to become independent in the way that you use the Linux operating system. And I really can't wait to show it to you. So for that goodness, I'll see you in the next video.